Okay, so 4-7, your goal is to be able to graph all 6 trig functions. Your assignment today is going to be using your graph to find values, but they're exact values. So should you already be able to reason through them and find them without a graph? Yeah. So, and we'll do that after we get them graphed. But the main thing today is to be able to graph them and construct it. So we're going to start with the first graph you have is sine, yes? Okay, I don't have it on here, so you have to help me make it on here. Okay, so we said this dotted line was 1, yes?
Yeah.
And this is negative 1?
Yep.
Okay, so I want to make sure I've got a color I can see. Okay, so what are some critical points for sine?
Okay, you start at, okay, yeah, 0. Never mind.
Okay, so 0, and that's right here, I think.
We're drawing this on the sine graph. Right?
You weren't drawing anything, I am. You're not drawing anything yet. You are looking at your sine graph. Everyone, this top one. Soon it will look like this. Okay, so 0. What's my next important point that I had? Pi over 2, and it's what at pi over 2? 1. Because the sine at pi over 2 is 1, right? Okay, what was the next one that I had?
Pi on the
X-axis, because these are all quadrantal angles, and sine is what variable, x or y? Y. And what is the y at pi? 0. Next one?
3 pi over 2.
3 pi over 2.
-1.
And it's negative 1 because the x at 3 pi, or the y at 3 pi over 2 is negative 1. And then my next one?
2 pi.
2 pi, and it is,
On the x-axis.
okay. So we've completed one cycle to the right, correct?
Yep.
And then what are my left critical values?
On
The same, but
negative
like-
pi over 2 is beyond negative 1.
Okay.
Then negative pi is on the x-axis.
You want pi over
Negative 3 pi over 2 is on 1.
2
Can you slow
negative 2
down?
pi on the x-axis.
You are.
Riley is on the ball. And this again should be already be on your graph, right?
Yeah.
Okay, and then negative 2 pi over 3.
No, it'd be
Or
negative 3 pi over 2.
Yeah, that one.
It's beyond 1. And then negative 2 pi is on the x-axis.
Okay.
Guys, come on.
Okay, you got it.
Shh. People. So this is stuff you should already know. We got these from our exact values, right? Okay, so what of my other trig functions go with sine? What's the other trig function that goes with sine? Cosecant. What's the relationship between sine and cosecant?
Opposite.
They're reciprocals. Let's use our big kid words. Reciprocals, okay? The reason why we want to use the reciprocal because the opposite can mean so many things, right?
Yeah.
And I probably should have put a little bit over here to show that it keeps going, right?
That's what I did.
You did? Good.
Yeah.
I'm glad we think alike. Before we go, I want to do one thing. What was the domain assigned?
all real numbers.
Ooh, I love my marker up here.
Is it recording?
Yeah, it is. But it's because it's, I don't know, it does stuff weird up there.
It's okay. We're all weird.
Okay, and what was my range, my y values?
Y
Right.
such that negative 1
Is
less than greater than y, less than greater than
Okay, so negative 1 is less than equal to y, which is less than equal to 1. Okay, that just says, we bounce back and forth, right?
Yeah.
Okay, so that's our sine, and hopefully your information isn't written on the graph. Mine just don't have enough room. We're going to go to cosecant, because cosecant and sine are reciprocals of each other. Okay, so now this is when you're going to start, okay? So we have to remember what's the reciprocal of what. We're going to add a few numbers in there, but we'll do that in a second. So we're going to start at 0. What's the reciprocal of 0? 1 over 0. Undefined. So when something's undefined in a graph, what do I get?
Nothing.
An asymptote. So we're going to put a dotted line right here.
At 0?
At 0. Because the reciprocal of 0 is undefined.
You want
Use
to
a different color.
Yeah, do
If you would like to, I probably would do pencil first in case you make a mistake and go back over it in that different color. Okay? Unless you've invested in your erasable pens like I did.
Hey, where'd you get them at?
I get mine on Amazon. And you can get them at Walmart too. Okay, so I got another 0. What's it going to become?
Undefined.
It's going to be undefined, so it's going to be a what? Asymptote. So you're going to make an asymptote.
Where does this one go? Okay.
Where at? At your other 0.
At pi.
At every 0, I want you to make an asymptote. At every 0,
Even on the negative side?
yep, every 0, even the ends, because we're going to negative 2 pi to 2 pi. That asymptote kind of curved, but that's okay. So I should have how many asymptotes?
5.
5. Negative 2 pi, negative pi, 0, pi, and 2 pi. Because when we reciprocate 0, we get undefined. What's the reciprocal of undefined? 0. When we did our exact values and worked on learning those, that was helpful, right? Because you don't learn both of them, you just learn sign and you reciprocate it. That's what I'm going to do with this, guys. You're not going to ever graph a cosecant graph without sketching in a sine graph. Because you know what sine looks like, yes?
So you need a sign
And
here.
so once I know sine, can I just reciprocate everything?
Yeah.
Yes, and that's how we're constructing this. That's what we just started doing. I don't want you to remember 6 graphs. I want you to remember 3
And then the opposite.
and then reciprocate them.
Reciprocate.
Okay, so, well, what's the reciprocal of 1?
Negative one. 1/2.
1.
1.
The reciprocal of 1 is 1. So we're going to use this point also. So I'm just going to circle it. What's the reciprocal of negative 1?
Negative 1.
Negative 1. And so we have another negative 1. And we have, so at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2, those are shared points, correct?
Yeah.
Okay, so now we need to think back to their other sign values. So we have the sine of 30 is a half, right? 1 over 2.
Yeah.
The sine of 45 is square root of 2 over 2. And the sine of 60 is what? Square root of 3 over 2. I don't want to reciprocate square root of 2 over 2, do you? No. I don't want to reciprocate the square root of 3 over 2. First of all, we don't even know exactly where those are at, do we? What about 1/2 though?
That's 2.
That's 2. Is that easy to graph?
Yeah.
Okay, so this is 1 on here. So you guys already had a 1 and a negative 1, right?
Yeah.
So that means every 2 lines, so this is 1, 2, so this is what? 2, and this is negative 2. So sine of, sine of 30, right, is 1/2, or sine of, what's 30 in radians? Pi over what?
Pi over 2.
30 goes into 180
Pi over
how many times?
Pi over 6.
6 is 1/2. So we need that pi over 6 in the first and the third and the fourth, all those quadrants, right?
Wait, what does that say on top?
Pi over, that's 30. Don't worry about that.
That's not a
Because we don't graph in degrees, do we? We only graph in what?
Radius.
Radians. So pi over 6, it's 1/2. So it's going to be pi over 6, and then what's the pi over 6 in the second quadrant? 5 pi over 6, because it's 1 less than a whole, right? What about in the third quadrant? 7 pi over 6, why?
Because it's one more than
1 more than a whole. Fourth,
11 pi over 6.
because it's
It's One less,
1 less than 2 pi. So we need to do that at those spots, right? And they're positive and negatives, yes? Okay. So, well, this is pi over 4 right here. So that next little line, not on the grid, but right next to it, if you look on your paper, you should see it better than mine. That would be 1/2. Well, just do it this way. This is 1. I'm going to do it a little bit different. This is 1, and this is 1/2, yes? This line right here is 1/2?
Yeah.
So every time this graph hits 1/2, we're going to reciprocate it to what? 2. So make a 2 point. So every time you hit the 1/2 line, or negative 1/2,
Is it supposed to hit that, I over 4?
no, it'd be pi over 6. It'd be, reference angle would be pi over 6. And pi over 6 is not marked on here. Pi over 6 is not marked up here. Okay, this is what? Shh, you asked too many questions, I can't even hear them. What line is that? Right here that I'm pointing at.
1.5.
1.5. What line is this one right here that I'm pointing at?
Ah,
Half. So what is the reciprocal of a half? 2. So every time my line hits 1/2, or what's this one?
negative 1/2.
Negative 1/2, I'm going to reciprocate it to what?
2 or negative
2 or negative 2. Do not worry about the grid marks. Pi over 6 is not even marked on here, is it?
Okay, so you don't worry
No.
about where it hits.
No, I want you to line it up with when you hit. So I hit here, so I brought it up. I'm hitting 1/2 right here, so I bring it down. See what I'm doing?
Yeah.
Every time you hit a half. Because these aren't perfect. We didn't have we did them ourselves.
That's what I was wondering.
Sometimes you'll hit a grid mark, sometimes you won't. At least the horizontal lines are perfect. And of course, I hit my domain in range. I'm going to have to erase my domain in range, guys. You got it, right?
Yeah.
Hopefully. You already had that wrote down, didn't you?
Yeah, you should have already had it written down. Okay, so does everyone have 4 on positive 2 and 4 on negative 2?
Yeah.
Yes? Are we still working on it?
I'm
Okay.
scared that I'm doing this wrong.
Me too.
That's why I told you to do it in pencil.
Oh, yeah, I should have done that because now I've
Okay.
got a wrong move.
You're not doing it wrong, as if every time it hit the 1/2, you bring the point to 2 and you bring the point to negative 2.
You have 2 on the positive.
Okay? Because what's the reciprocal of negative 1/2?
2.
2.
Negative 1/2.
Oh, negative 2.
Negative 2. So all we're doing is reciprocating those points. Could we reciprocate every single one of the points that fall on this curve?
Yes.
Yeah, but I don't want to do that. That's too hard. That's way more complicated than we need to do, right? So what happens at an asymptote? What's the graph do? What? It doesn't touch it. So if it has to go through this point, and through that point, what is it going to look like? It's going to look, what shape is that? That's a parabola. It's going to look like a parabola, isn't it? So we're going to draw ourselves a parabola. And that's not, it doesn't go. Make yours, my pen does not like it there. You know that. Okay, so it looks like a parabola. Does it ever touch those asymptotes?
No.
Nope. Because it's really, really close, but is it ever going to touch them?
No.
Nope. So what's this next one look like?
It's gonna look like a parabola.
But a reflected parabola, right?
Cool.
And it works better if you draw one side and then the other side, not like at one trying to do it all at one time.
Oh, I do.
Mine are all kinds of janked because my spots are kind of messed up.
Oh, that's okay.
Because like where cross was not good line.
It all works.
Do we go all the way down to that?
It will go forever, won't it?
No.
Like, was it ever gonna stop?
Wherever we want to
No.
stop.
Yep, just put your arrows wherever you want to stop.
I'm still shocked by that.
And then what's going here?
Still just mind blowing.
I am mind blown. How does it not touch the asymptote?
because at the asymptote it's undefined. You can't divide by zero.
It will touch it.
But it
Don't
will
fool you.
No, it will never touch it.
If it goes on
Mine did.
forever, yes it will.
No.
Mine's touching it right
Okay.
now.
Theoretically, yes, right now. Theoretically, you can cut everything in half forever and never get to the end.
Yes, but eventually it'll collide with it. You know what I'm wearing? Math is wizards. You know what I'm wearing?
Math is made up knowledge.
Didn't you know I had to go to like a wizard school?
She
Okay.
went to
Alex
Hogwarts to
herself.
learn math.
Okay, so do you see how we made sine, right? And then we got cosecant because we did what with everything? Reciprocated it. That's it. It's just like when we learned the exact values. I said don't learn cosecant. I said learn sine and do what with them? Reciprocate them. So now we're going to go through and we're going to write some stuff on here.
On that little side.
On your side is much bigger than my side.
No, I think my whole paper would fit in your side.
Yeah.
So, well, okay, my pencil I can't do. Fine. Okay, so we're going to go through domain. X such that. Now, it isn't all real numbers because what can't it be?
0.
It can't be 0. It can't be
Bio.
pi.
And
It can't be 2 pi,
Or
negative pi, or 3 pi, or 4 pi, or 5 pi.
Can't be pi.
It can't be any multiple of just pi, right?
X
So-
such that. Not
X such
equals
that.
pi.
Not equal to, you can't just put pi because that means right here. How do I make it any?
Multiples of pi. You're
What do
right,
I add to it?
multiples.
1.
Can't be an x.
Pi times a number.
N pi, and that goes for plus or minus n.
That's what me and Tori said back here, but
I'm sorry, I ignored you.
Wait, you can't put. Okay, never mind.
I can't put what?
Never mind.
Okay.
I just confused myself.
Okay, so n just means any increment of pi, right?
Yes.
Okay,
That's what I was trying to say. Multiples
I
of
know.
pi.
I knew what you were trying to say, but you haven't had to say it before, so you didn't know how. So that's what I'm here for.
Well,
Okay,
You gotta do it.
Gosh dang it.
R.
so y used to go from -1 to 1.
Now it goes from -2 to 2.
Does it exist in here at all?
No, it's dead.
Okay, never mind.
It goes from 2 on.
Negative.
No, not 2.
2 up.
-1 and what?
Negative.
And everywhere else.
And
Positive
then-
infinity.
So less than -1 or
Greater than
one.
Great.
not -1.
Or 1.
Positive.
So y is greater than equal than 1 or y is less than equal to -1. Now you could put y is less than equal to -1 or either way. But it's everything 1 or bigger and everything -1 or smaller. Because everything in here is reciprocated, yes? And any number between 1 and 0 that's reciprocated is bigger than 1, isn't it? What's the reciprocal of 1/3? 3. What's the reciprocal of 1/85? 85. Okay? So anything that happens in between 1 and -1 for sine, it blows up when I reciprocate it, doesn't it?
Yes.
Okay, what other things we got on there? Period, right?
Yeah. And everything.
Period and amp. So period is the amount of time it takes to repeat itself. Okay? So we're going to start at 0 and go right just because it's convenient. Because it doesn't matter. We know that, right? Yeah. Okay. So we have a positive parabola here.
3 pi.
Okay, just a second. We got a positive parabola here, so that's all those values, right? And I got a negative parabola here. It's just from 0 to what?
2 pi.
2 pi, which is how much? 2 pi. So the period
The
is,
next parabola is going to be positive.
Right.
It'll have a positive
now I'm
value.
going to tell you in your book, they show you this.
What do you mean?
They show you from
Show
here
you the board?
to here. But how far is that? Negative pi to pi is how much?
1.
2 pi.
2 pi. Does it matter where I cut it?
No.
No.
No, as long as I get 2 pi. Could I cut it at negative pi over 2? And then where would I cut it over there?
5 over 2.
No.
Positive.
I've got to get this other half.
You have to cut it.
Positive
out.
3 pi over 2.
Positive 3 pi over 2.
Because it has to equal 2 pi.
It has to equal 2 pi. Could I cut it anywhere I want as long as it's 2 pi?
Yes.
Yes. Okay, so using this graph, could you tell me where the cosecant of theta was negative 1 at?
What?
Can you tell me where the cosecant of theta is negative 1 at? So cosecant of theta equals negative 1. So I'm looking for theta, right?
Okay.
So where does cosecant of theta equal negative 1? Look on your graph, it's probably easier to see than mine. Negative pi over 2 and
3 pi over 2.
my 2's down there. And 3 pi over 2. All you did was look and found negative 1, right?
And then you found
And
the
find
limit.
your angle. Now, does it go on forever? Yes, because this graph goes on forever. I think in your assignment they give you a limited domain. I don't know if it's from negative. I think it might be from negative 2 pi to 2 pi.
I messed up.
But just read whatever they say. If they say from 0 to 2 pi, what's my answer? 3 pi over 2. Correct? So this is how you're using your graph. If it's from 0 to 2 pi, I only have one negative 1, don't I? If it's from negative 2 pi to 2 pi, I have how many? 2. So just make sure you read. Okay, and it says use your graph. Could I also do this with just my triangles? Could I answer these questions with just my triangles? Yes.
Does
I
that
could.
say 0 equals negative pi over 2, 3 pi over 2?
No, that's theta.
So theta equals negative pi over 2?
Yes. Because we have cosecant of theta equals negative 1. So theta is my variable. So yes.
So if you're just wanting, okay, if it asks for the theta, it's wanting all of them, but then if it asks for just 0 to 2
It
pi.
gives you a domain. I don't remember what the domain is. I can't remember if it's negative 2 pi to 2 pi or if it's 0 to 2 pi.
Okay.
I can't. It's one of those two. Questions before we go on to secant? Oh, amp. Yes. Can anybody guess why I'm forgetting amp?
It doesn't matter.
Is there one?
No.
No. Because the
No.
amplitude, there is no amplitude because this doesn't stop at any point, does it? So amp is
None.
none. There is no amplitude because there isn't one. This graph does not bounce between two things.
It's fake.
Do we have to graph this? Is it not going to be like a Gauss method? Like in the equation?
There can be, but it won't. It's not affecting the amplitude. It just affects how quick this parabola goes up. Well, actually, what will happen is when we graph these, when we graph them, we're going to do very basic ones first of all. But when we graph them, you do a sign and then just bounce off what you have for the sign. So did everyone get that? What I said?
Before the assignment, you want us to do a sign graph.
No. She asked when graphing. We're not graphing today.
Oh.
Okay, you're not graphing today. But when we do, we're not going to graph a cosecant first. We're going to graph a what?
Sign.
A sine, and then we're going to bounce off of that. So the A isn't really going to affect the amplitude, but it is going to affect the range, isn't it? Because if the amplitude was 6, it would be everything greater than 6 and everything less than 6. So it's not going to affect the amplitude, it's going to affect the range.
So what are we doing?
You're using this to find exact values. It says this on your paper,
Okay.
and your answer was negative
Oh,
5
okay.
over 2 and 3 pi. That's what
all
you're
we're
doing.
doing?
Yes,
Are you sure?
positive.
I don't know.
Okay, so cosine, I don't have it graphed yet, but I'm gonna go quicker because I know what you guys can. We can do this quicker this time, right? Okay, you should have cosine on your curve already. What's the critical values for cosine?
0.
Negative 2 pi.
1,
Okay.
and then at pi over 2 is
Negative. Nope.
Zero.
0.
Pi is negative 1. 3 pi over 2 is 0. 2 pi is 1.
I think
Pretty
that's
much
3
did
pi
it
over 2.
Riley, so.
Okay, so I'm not gonna keep asking because you guys know.
Yeah,
Right.
This is secant, right?
Yeah, that's what I thought.
Well, yeah, it will be secant.
Look at her go.
Okay, so cosine's in blue. And this one, I'm gonna do secant in red.
Ooh.
Because you have cosine written on the left, don't you?
Yeah.
Okay, so again, we're gonna do exactly the same thing. What did we do first on the other one?
You.
Go to
And your
over zeros and make
Asymptote.
asymptote.
All my zeros are now undefined, so make your asymptotes.
So everywhere it goes 0 and make it asymptote?
Everywhere it goes through the x-axis, give it an asymptote. Fine.
Oh wait, I'm doing this wrong.
Yeah.
I'm so bad at drawing dotted lines.
Me too. Just draw a line and then erase like little marks.
I think it's easier to do dotted than a solid. How many do I have on this one? I don't have 5, I have what?
Yeah, 4.
I only have 4 because I cut it between negative 2 pi and 2 pi, right? Do these continue forever? Yeah. Okay, then what? Are you guys done with your dotted?
No.
Okay, sorry.
People usually
I'll just fill in the cosine
What?
information real quick.
People use these graphs in real life.
Actually, anything cyclical can usually be assigned to a trait.
Cyclical.
Cycles, anything that
Oh.
cycles
I like that
can
one very
be-
much.
can be used, can be graphed in probably one or combination of them.
Basically, no big.
Sine and cosine are used, well, sine and cosine are basically exactly the same curve translated. We know that. They're used in sound all the time. When they do earthquakes, they're trigonometric. So yes, they are used.
The people just sit down and like draw one, know to draw.
At this point in time, it's the computer, when you draw, it's usually, when somebody draws a graph, it is usually through a computer.
Because
It's
handwriting is
writing
flawed.
the equation, it is writing the equation that is usually done by hand. Because you have to experiment with what you're adjusting. Okay, so now what did we do?
We did the half.
Circle the.
We did
No, we
the
didn't.
half.
We circled the ones and
The shared
negative ones, the shared points. Why is 1 and negative 1 a shared point?
Because it
They're
is.
the same thing.
Because they're the same thing. The reciprocal of 1 is 1.
Can we do the one that's outside of the left asymptote?
Yes?
Okay.
Why would you leave it out?
I don't know, because it's not the asymptote on the other side.
Well, there is. We just don't have it. We don't have enough
You
paper.
can't see it. So you want us to finish out that dotted line?
No. The shared points. So 1, the reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1.
Let's talk about
The
it.
max and mins.
Yeah, I know. Now you do the positive and negative half.
Well, I didn't mark 1 or negative. I didn't mark 1 or negative 1, did I?
No.
So then we need to mark what? 2 and negative 2.
I don't understand how you're doing two. Like,
Okay.
you're going up two
Yeah.
from one.
What? Okay. Here's 1, 1.5, 2. Is that what you meant, Riley?
Okay.
The dotted line's 1.
Okay. So this time we need to think about cosine. Where is cosine 1/2 at? No, 30 was sine.
So
More
60.
So 60.
Boom. Or
So pi over
good
3.
program.
Yes. I was gonna write 3.
Oh, I know.
Thank you, Tori. I was gonna write 6.
You were?
Yep, for 60. I always do that. 6 for 60, and it's not.
I do that too, but
It's not. So pi over 3 is where I'm going to reciprocate. And again, this isn't marked on there. You do not have increments of pi over 3, do you?
No.
Nope. But that
Actually,
means
yeah, we
every
do.
time
Yeah,
it
we do.
hits.
Yeah, we do.
You do?
Yeah, my half is
Okay,
a pi
I
over
can't read mine for pi over 3. I can't even read my numbers.
right after the problem.
Okay, well, if you happen to hit 1/2 at pi over 3, which I don't
did.
think I did, you did you?
I do.
I
Right
hit
before.
one half.
Okay, anytime it hits positive 1/2 or negative 1/2, you need to reciprocate it to 2 and negative 2. Okay? So
it's still 1/2.
listen, please. Do not worry about your scale if it's not perfect. Got me? We need to know this is 1/2, yes? And this is negative 1/2. So anytime it hits one of those two lines, you're going to reciprocate it.
That's negative
That's
1
negative.
and a half.
Oh, I put it the wrong one. Thanks.
You silly girl. Silly girl.
Chili goose.
I wish I had your paper,
And you
not
also drew
mine.
the line wrong on the side. where you marked it.
Oh, I did.
Hey, another thing is, that one on the very far left
Yeah.
half. How are we supposed to mark that one if we don't have the line finishing?
Then you can't.
Okay, so we don't?
No.
Okay.
Do not only what you have. So anytime it hits 1/2 and negative 1/2, you're supposed to do what? Reciprocate it to 2 and negative 2.
You want to draw the curves.
If you feel confident in that, go for it.
The parabolas.
Yes. Thank you.
Yeah.
Keeping us honest.
I know. Hey.
Oh, I got my parabolas drawn.
Good job, Evan.
Thanks.
Is it still where it meets at a half?
Yes, still where it meets at a half. If it happens to line up with your curve, great. But mine don't. I know they don't.
What about the ones on the end?
Okay, so the ones on the end, I don't know this left, do I? So I'm just gonna draw the part I know. I can see.
Wow. Looks like a DNA.
What the heck?
I think I did something wrong.
Wait, we're supposed to draw a little arrow at the end?
Well, they go forever. So.
Yeah, if you don't, then it doesn't go forever and it's not forever.
It is still a parabola. It's just a
Remember,
parabola
It'll
that stops.
never hit the line.
Yes, then it will definitely never the line because it stops right there. One spot.
Good.
Okay, so if you look at top and bottom, again, here's mine, here's yours. This is about what it should look like.
Yeah.
They're basically the same, yes?
Yeah.
Just shift it over.
It looks like DNA. I don't get why
And
they're
you do have a crippled hand.
Why is there a difference? Because sine and cosine are translated by pi over 2. So if I took this graph and I translated it pi over 2 to the right, I would have exactly the graph above it.
I just don't get why there's two different graphs for like.
Well, because sine and cosine are 0 at different spots, and it's all dictated by your asymptotes.
No one understands this.
Okay, so we got our picture?
Yep.
Okay, domain, be careful. X such that
What'd you put for the SEC?
Positive, negative.
secant, SC. We can't be pi's over 2, right? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, right? Is that what I can't be?
Yeah, you can't.
Look
be
at your
number-
paper. My asymptotes are at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, then it'd be 5 pi over 2, and 7 pi over 2. Okay, those are all how far apart? Pi. We're still pi apart, right? But the first time I can't happen is at what? Pi over 2. So we say x cannot be equal to pi over 2 plus or minus, and how far apart were each of these?
Pi.
Pi
And pi.
and pi. Now the last one, the reason why we didn't do a starting point, because the starting point was 0. Wouldn't that look weird to say 0 plus or minus n pi? That would look funny, wouldn't it?
Yeah.
So we don't, because if n was 0, it would be 0.
Wait, did we have the x cannot equal on the domain on the cosecant graph?
Yes. Cannot equal n pi plus or minus n pi.
That's still really confusing.
Okay, because
Okay.
every time we hit pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, it's going to be an asymptote.
Yeah, so therefore. you
And
can't
if I
make that-
start at pi over
like
2,
the boat that Nemo
all of
had
those are
with
pi
that boat.
apart, which would be 2 pi over 2, common denominator. So that's where I get 1 pi, 2 pi, 3 pi, 4 pi. Okay,
Yes.
range is exactly the same as cosecant. So y such that y is greater than equal to 1 or y is less than equal to negative 1.
Boom, and then the
You tried
period
the
equals
other
2
way?
and the amp equals 0.
No, the period is not equal to 2 pi, thank you.
No, sorry, 2 pi. I had
And
that
the
on my
amp
computer.
does not equal 0.
It equals none.
It equals none. I don't know how you can equal none, but okay. Is none.
You
There
said
is no amp.
It equals none.
Okay, so now could I use this? Could you tell me where the secant of, ooh, here's a good one. Here's a trick. The secant of theta equals 0.
Oh.
Where is the secant 0?
Pi over 2, negative pi over 2.
Wherever it
There
crosses
isn't one,
0.
3 pi over 2.
Okay, what's our range? Up more than
0
1?
pi.
Oh,
Less
it's not,
than
it's
what?
non-existent.
Is it ever 0?
No.
No.
Oh.
It's gonna shut off on me, guys. No
Did it
solution.
stop recording?
No, it's still recording. It's the
You
other.
always give us attitude when you ask. Well, you're the one that told us to ask
Yeah.
that.
You
No,
are the one.
It's
who
not.
did
I'm
it.
not on that anymore. I'm not on that one. Somebody dropped a pin.
CJ,
I think
can you
it's
please
CJ.
pick up my pen?
I
Was
will in
it-
a second.
Okay, so it's no solution. When it quits catching up with my pin, I know it's either lagging or I lost connection here. Okay, so no solution. So do I need to pay attention? Like, what if I ask you where was it a half at? Is it ever a half?
No.
Because when you're asking for like the secant of theta equals 0, you're looking for like the y.
I'm asking for the x's. I gave you the y.
So that's the y. That's what I was
The 0 is the y. I gave you the range.
okay.
I'm asking for the domain. The domain is the input. Okay, how much time do we have? Are we still good?
2 minutes.
Like
No.
3 minutes.
3 minutes. Okay, we are going to have to do tangent tomorrow. We are gonna, because we'll do tangent and cotangent on the same graph also.
They're gonna do
So
it
in your, just a second, let me answer. On your assignment, you should know them. They're all exact values. But if you want to wait and do the tangent, cotangent ones till tomorrow, you can do those. But do all the rest. There's only like 8 problems anyway, I think.
I'm gonna
Okay.
guess on the cotangent and tangent.
Is it already posted on class?
And see if I can
Yes,
figure out.
I think so.
And see if I do it right.
Mr. Murphy, do you